Yeah.
Okay guys, today we're going to solve a really hard question regarding Coulomb laws. So let's dive into it and start to solve the question. So the question we have is actually a sphere. Let's draw a sphere. A sphere, here it is. This is the sphere. And this sphere is actually a charged sphere, which means that there are some charge distributed around this sphere. Okay, so let's do charge sphere. How this charge is distributed in space. So I'm going to give you the distribution charge. It's an area distribution, which usually we signify by sigma, and it's equal to some constant. And now comes the baddest thing, sinus theta. And who is theta? If you remember the spherical coordinates, theta is actually, if this is the z-axis, this is x, this is y, sorry, this is x, and this is y. It's important. Okay? So theta is actually, if I want to look at a specific location, this kind of a dA, a small area that built the sphere, and I actually brought a cool thing to show you. Because I know that it's really hard, to think about the 3D, so I brought this thing. You know this thing? This disco ball? So this disco ball, let's put it close. You see that it's divided to a lot of squares. You see it? A lot of squares. And each square is actually a dA, okay? And if I'm going to sum them all, I can build the sphere. That's the idea. Of course, it's not perfect. There's a space between the areas. But if I go really small dA, it's going to look just perfect, okay? So that's what I want you to think when we're talking about dA. So where is this dA located? It's located, if I in 2D dimensions, right? I only the sphere. I know it's feel like we're in 3D, but no. You're only walking on the sphere. The dA only distributed around the sphere. Join us. So we didn't cover much. Don't worry. So this angle, theta, is the angle between this z-axis and this area, this small area. This is theta. And as we said, we need two coordinates. If you're going to open your ways need to know two things to let you know where to go. You need to know some coordinate in this direction and some perpendicular coordinate. The same thing happened here. So the second coordinate that we're actually needing is theta. It's a phi, sorry. And phi is the angle from the x-axis. I like to think about it as a sniper. Okay, if I'm a sniper, I have this angle shooting to the sky or shooting to the air. So it's running from 0 to pi, and I also have this phi. Phi means where to shoot, where to go. This is phi, this is theta. So they're telling me that the charge is distributed in this orientation, okay? How sinus looks? Remember sinus? Sinus, I'm investigating what's going on here. This is dA, or actually this one can be called dQ, which is equal to area multiplied by the charge distribution, which we know is a function of theta. Okay? So how sinus functions look? Start from nothing and then I become something. So from 0 to something, right? And then it's diagonal, right? In that manner. Agreed?
Yeah.
Okay, this angle is pi over 2 and this angle is pi, right? So, come and join. We just started the question. Okay, we have the sphere, charge, sigma. Okay, guys, you with me?
Yeah.
Okay, so I want to know what they asked me. They asked me, okay, there's a charge, and if there's a charge, there's some electric field, right? Because each charge like this produces electric field to all directions, right? Radially, each small charge. And they asked me, what is the charge here? At E, Z equal R. R is the radius of the sphere. Where it's going. So the first thing you need to do is to look at the charge distribution as we did. And try to understand what's going on here. Okay? So if I'm looking, let me clean the board a little.
just, you wrote before dA with the small...
Yes, and then I said let's be more specific. This one is, the area is dA, but the charge is actually dq. Okay, small dq, and what I wrote here is the charge distribution. Okay? Perfect. So I want to understand what is the electric field. Okay, I can sum up all the dq, right? And understand what is the electric field, but it's going to be a messy work. Why? Because if I have this electric field, the sum equal to the whole equal to the sum of its parts, so I can do this, but it's going to be really hard work because this one is a vector, right? So we want to understand if we can maybe look at an easier question. That's what's always happening. If you have something really complicated, it's gonna be simplified to one of the direction. Maybe two, but not three. Three is really hard. Three direction, X, Y, and Z. It's really hard. So let's observe the sphere and try to understand if we can see where is the direction, what is the direction of the electric field, where is it heading. So just, let's see what this charge doing. It's all positive, all the charge are positive, you see it? All the sphere is positive. This is positive, this is positive, everything is positive. So every charge repels electric field, right? It's like shooting it out. So this one is shooting out electric field, boom, right? And then I have another charge on the other side, right? This one, which is the same, right? If you add the same theta, everybody here is the same. And here they are weak, and they become stronger and stronger and stronger and stronger until here. Here the charge are at the maximum value, right? At theta equal pi over 2. And then they die out. But the symmetry is that it's happening in every cut of the sphere. Every cut of the sphere. You with me? Why the zoom die out? The camera? Wait, it's not the recording.
What did you do?
Okay, never mind. Okay. Okay? Perfect.
Wait, but why is it plus in the...
Why is it what?
Why did you write the plus in the sign function?
The plus, I want to emphasize that all the charge is positive because the sinus is positive.
Okay.
And this term is also positive, so we're talking only about charge that repel electric field, shooting it out. So, and we talked about also the strength of the charge. The strength of the charge is, here the charge really weak.
Yeah.
Here's the charge really weak. You with me?
Yeah. Just 1 second.
Yeah, because
She's in charge of the zoom, okay?
Yes.
So you need to head to the camera, not to me. Not to the camera, to me. We're helping the Zoom people. You are actually have the privilege to see us on YouTube, so you have a better quality video. Yes, and down with that, you right now are going to be in charge of the Zoom, okay? Because you see the TV better than your position. Okay? So next time you're going to have a opportunity. Okay, if you want, don't worry. So here I want also to talk about the sinus, about how the charge behaves. We see that here the charge is the strongest, right? At theta equal pi over 2, right? This one. The strongest are actually distributed around this. And it's become weaker and weaker and weaker. This is really weak, and here you have zero charge. That is the point. This is pi.
Why is that line pi over 2?
What?
Why is that line pi over 2?
Because how you define theta?
Starting from
Theta is starting from Z position, and then I start to open the angle. This is pi over 2, and this is pi. Okay? I think about it as a sniper with standing here.
And you don't start from the y-axis?
No, you actually start from above.
You start from the position where you're asked to calculate the electric field?
Okay, in general, when we're talking about sphere coordinate, that's the convention. The convention is that you have theta and you have phi. Theta said how much I'm pointing upward or downward, and phi actually said where do I want to shoot? At the enemy or
But phi starts
on
from
us?
the x-axis?
Phi live on xy.
Phi is like
But
for
it
the field,
starts-
right?
It's for the xy.
Switch from what we did.
It's xy.
Yeah, I know, but it starts from the
It starts from x.
Okay.
Agreed. It's opposite when you're talking about 2D, right?
Yeah.
You have theta here.
Yeah.
Agreed? It's a mess, but this is the convention. Sometimes the convention is not that nice. You know why your keyboard actually designed that way? Why it's not A, B, C, D, E, F, G? Why? You thought about it for once? Let me tell you why it's happening. Because the typer was so fast that the machine was like this long arms that hit the letters on the paper was so fast that what happened before this one could come out, this one stuck.
Wow.
So engineers and scientists sit down and thought, how we can slow them down? And they said, I know, let's make the probability of letters that are gonna do the typer as slow as you can, the weakest fingers, let's do it. They did it, solve the problem. But technology changed, stuff changed, and right now we're stuck with this keyboard. That slow us the most. And they'll try to do a new keyboard which is gonna make us fast and nobody wants to buy it. Everybody's so used to this darn thing, okay? So convention sometimes take us back, okay? But I agree that it's different than the case of 2D. When you
So
have
you're explaining that.
X and Y, agreed, and this is theta usually. Here it's phi, okay?
So here at the XY plane, the
Phi live at the X, Y.
no, but the charge is the highest.
The charge is the highest at the XY plane because it's have the angular equivalence. Okay? Understand till now, okay? So I clean it a little bit because it's become messy, and we want to discuss this charge, okay? This charge here, clean the sphere, clean the sphere. So I have this particular charge over here, this one, okay? You can draw a new sphere if you want. This charge here, and I ask, how does it affect on the charge, on the electric field here? What does it do? So it repels. Oh, that's what happening. This one do that. And there always, if this one has some phi, right? This one actually had some angle phi. There's another charge in the other side, right? With the minus phi. Agreed? A middle charge. And sorry, not the minus, yeah, minus phi. Minus phi. And what this charge gonna do? It's gonna do this thing. Said, I want to shoot electric field from me also. And it's gonna do this thing. And what's gonna happen? They're gonna sum up in that direction, these two vectors, and they're gonna cancel up in this direction. These one are equal. You see it? So the main goal was to understand how the electric field behaved at that point. And what we actually revealed that the electric field is not dE. It's not this one only. Sorry, it's not this one. This is dE. It's not this one. It's just a different color.
It's just the one going upright because.
Yes, because somebody from the other side, right? This is dE. Someone from the other side gonna cancel it out. This plane, right? And we're gonna stay only with what? With this, which is dEz. It's the only thing that's gonna stay out. You understand?
Which is easier to calculate than if it was in the
Definitely, definitely.
How do
This is a vector. This is 1D. This is only the Z axis. I understand from this picture.
So it's like an integral with two variables on one? That's the
3
Why 3?
x, y, z.
But it's
In space, x, y, z. In space. The sphere living in space.
Yeah.
So that I can actually make it easy and look only at the contribution to dEz. So the question now is how we continue and said here dEz. That's what I want, with some correction. I need some correction. But I know that this one equal to that in one direction, the z.
But how do you know it will behave exactly the same all over? Like,
Let's think about it. If you didn't saw it, but it has a really cool sphere today. Okay? And this sphere is actually have the LDA. You see it? The disco ball?
where did you
Yeah,
buy it?
Huh?
I want to buy this.
Okay, I'm starting to sell this on Amazon, so I'm going to put a link below. Joking. Okay? So what I want to say, so I want you to look at the sphere. Okay? Now you're going to close your eyes and you're going to do this. And stop.
It's the same, but there's,
It's the same.
but
So,
there's one point.
so this dA,
There's one point that doesn't have another part.
this
number.
dA, actually gonna have this dA on the other side, you see? We're gonna do this thing. And I can do it all along, whatever
But
I
there is
want.
one point that doesn't have a partner, no?
What?
The point in the middle.
This one. And where it's direct,
Up.
right?
And the origin.
And what?
The origin.
The origin, there's nothing in the origin. It's a sphere. It's not a solid ball. It's a sphere, okay?
It will be relative if it's like a positive charge and negative. If it's a negative charge,
Yeah, since it's going to be negative, it's going to point downward.
downward.
So you're also going to have dz, but downward. Understand?
Makes sense.
Perfect, okay.
And then it's also down. But
Yes.
if it was also a full ball, then it would be.
It was full ball. It was different question, not sigma.
Okay.
This was a row,
Yeah.
right? And the harder question.
Okay.
Okay? So this is really similar to the problem that we had with the plate. It's the same question actually.
So the
Same
idea
question.
is that the whole contribution is only in the z direction.
Yes, and you need to find how to find it. And now comes the part which is not physics, okay? And you should have this understanding of calculus and geometry. And it's simple. It's really, really simple. You just need to watch out, okay? What we're interested in when calculating dE, we're interested at the distance, right? Where's the distance? This distance. This is d. We're looking for this d. And we can count it. We're looking for this d, okay? And I can draw out a triangle that can help me find this d. What I know the radius, right? So I can do this. Radius, this is dying. D, this is R, and this is R. You all see this triangle, right? You see it, okay? So I'm gonna contact you to what's going on here. We try to find the electric field from that point. At that point, we have this sphere which is charged, and how the charge behave that way. It's all positive. Get maximum at theta equal to pi over 2, and got again 0 at pi. It's accumulate charge until here, and then it's dying out. We understand that all the charge is pointing outwards, all the dq pointing outwards, and that gives us this dE from each charge. But if you look at two charge, here you have this sphere, two charge, one over here and one at the other side, they're going to cancel out this thing. And they're going to sum up this thing. Okay? So right now, we don't want to solve this. This is going to be pain in the ass. Okay? But we do want to solve it in an easier form. We understand that the electric field is going to act only from contribution at the z-axis. The x and y are going to die out. Okay? So I want to find that. So we know that we want to find dz. Okay? Sorry, dE. And we need to put here some correction. Okay, let's see correction. Some correction function. We're going to make it actually dz. Okay, dez. That's a general idea. I'm moving to this board. Camera people, follow me. Okay.
Why do we need the distance d?
Well,
Let's draw it. Okay, we have E, the electric field, which we don't know, but we know it's building from dE, right? Okay. And we want to make this dE actually dz, because we understand that only this thing actually counts.
Yeah.
Okay. What is dE? Let's remember what is dE. It's, guys, it's your time. What is dE?
Okay.
it's
dE. K. Good.
dq over
dq. Good. What else?
the magnitude of the vector.
Yes. D square
Square
and the direction. Right?
Yeah.
This is what we have. Okay?
It's only one charge?
Ah.
One charge only?
It's dE. It's one. It's a dq. And we sum up right now the dq's. What we're gonna change it. Okay? So we need to find this d, and we also know that what really matters is this thing, right? If this is dE, this, let's call this angle is actually what? This angle is actually theta, right? Where is the specific charge? The charge is a function of what? Theta,
Theta.
right? Phi and theta. Agree. Phi and theta. Okay? Phi and theta. This is the charge, where it's located, right? And also d. is a function of phi, right? Where it's located. Because this one have a different distance. And this one have a different distance. Agree? Perfect. Okay, so if this angle is theta, and this is al, and this is al, let's draw it big. D, theta, right, al, and al, I can say that this is alpha, right? Agree? This is alpha. And what's the value of alpha? Alpha equal to 180 degrees minus theta divided by 2, right?
90 minus.
Agreed? Because the sum of all angles, these two alpha plus theta, actually equal to 180 degrees, which you have in a triangle, right? So I know this alpha. Alpha
How
is,
do we know that it's alpha and alpha?
I just define it alpha. Why I define alpha? Because I have here alpha, and then I know the connection between DE and DEZ. What the connection is? This is DE, right? And here I need to put some correction, which is sinus, right? It's sinus
How
alpha.
do we know it's alpha?
Mhm.
Because I know.
Wait. I just want to be sure. Sinus again. Why put your cosine? Oh, wait a second. Sorry. This is not alpha. This is alpha. Okay? Are you with me? I had a mistake. Something was looked wrong. So this one is cosines alpha. Okay? I'm cleaning this. I want you to see that.
It's supposed to be the direction.
This is DE. This one is DE at the Z direction only. And the direction is down for sure Z. You see what we did over there? Just putting this thing here, and we can look only at the DZ and not at the DE direction, which is really complicated. Okay? Because this thing that we had before was pain in the S. Okay? So we actually get rid of it.
But Ron,
Yes.
what will be the value of this cosine? Because we like just defined the angle and like we.
What's going to be the value of the cosines?
Yeah.
Okay, let's see how. Cosines is actually equal of alpha, and we just declare what is alpha, right? We said that alpha equal to what?
180 minus theta.
180 minus theta over 2, right? Degrees.
It's basically sine of theta over 2.
Perfect. It's sine. It's equal to, if you're gonna organize it, it's actually sinus theta over 2. Okay? That's good. Simpler. Agree. Okay? Perfect. Okay, so right now we still fucked up. Why? Because we don't know this D, right? So how we can find this D? We have this triangle, this one, this green one, and we can find it out from that triangle. There's so many methods to do it, okay? It's up to you what is preferable to you. I use the sinus sentence, which said that each angle that I have, the length that I see in front of me equal to the rest. So sinus alpha actually equal to R. So we actually can get D out of the equation. D equal, and we know this, right? This one is, and we can put that inside and have another connection, right?
Cosine theta over 2.
This is
Cosine of theta.
This is cosines of theta over 2. Right? We can join between them. They connect to each other. Each one define the other. You see it?
They're complementary.
Yes, perfectly. So we get these actually equal to 2R sinus theta. And when this theta over 2. And then where these 2R actually came out of, I use that one.
Half-angle formula.
I use that one and use it as I use a sinus theta equal to 2 sinus theta over 2 cosines theta over 2, because I want to get rid of these cosines. That's a trick that I did. This is not relevant to physics, agree?
Yeah.
This is the background, okay? I know it's sometimes hard, but that's the challenge that comes with the homework. It's not relevant to the tutorial or the lecture.
But
Okay.
if we have something like that on an exam, it's too bad.
Promise you that the exam is going to be easier because we don't have the time
Yeah.
to ask really hard questions, okay? Really hard math questions, okay? But you should be smarter than us, okay? You should see, okay, fuck, I need this stuff. Let's write it down for me. So I'm going to have the exam. You have a paper sheet, right? Start to write down what you need for the exam. Good?
So we found the D and
We found D. Actually, we found almost everything. Let's clean the board. Let's clean the board and see what we actually have. Okay? Now we see that E equal to what? To K. dq. What is dq?
dq is dA times.
Perfect. Okay, so it's actually dq is, and what is dA?
It's radius d theta and radius sine theta, sine phi d phi.
Perfect. Let's remind you that because I think this is the hardest.
Oh, sorry. Let me.
Right? This is the hardest. You follow with the camera?
Yeah.
Yes, I am.
Yes. Okay, Glenn, wake up. Everybody count on you.
Don't sleep.
Okay. So where comes this dA? You see this area? You see it? We want to calculate this area. We know that this length is actually L d theta, right? We know it for sure. It's L d theta. And this thing, what is it? Let's see at the shadow. We can see at the shadow what is this distance. What is this distance? It's not L, it's some shadow of L. You see, this is L.
Yeah.
This is its shadow. Shadow doesn't mean it's the same length. So this is a shadow R, a shadow of the real R, dt, d phi. Let's find this shadow.
But
This-
what you're drawing now is on the shell
No, it's inside.
inside. But
It's
what's
inside.
the point of drawing it inside?
Just
Because you can, so you can see this distance from the middle.
Okay.
Okay, so what is this length? And what is this shadow? Is actually, as we said before, if this is phi, right? You can find from this triangle, this triangle. You can find that this is, you sure it's phi? Let's be sure.
Yeah, it's sine.
Yeah, I think also, but I just want to be sure.
It's
No, I think it's theta. It's not phi. Because you use actually this triangle also to find it.
Yeah, because like in Calc 2 we have.
This is actually, you see that this is the same as the shadow. You see it?
Right.
This thing is the same. So we actually have here theta. Sorry for that. Okay? It's good to be wrong. Why?
No, because like in Calc 2 we have a different notation.
I agree, the different notation. But it's good to be wrong. Why? Because now you're going to be more careful about it.
Right.
Okay? So it's good to be wrong. Don't be afraid of being wrong. This is the best advice I can give you in the academy. Okay?
So it's
Don't be afraid to be wrong.
Theta
It's important.
d phi.
Huh?
It's sinus theta d phi.
Yes, it's r d theta, so it's r squared actually. Sinus theta, d theta, d phi. This is A. Horrible A. dA. Agree.
But how
Horrible
did you
A.
get the R star d phi?
Al star from this triangle. This one, this is this. Okay, it's the same. It's the same. It's a little confusing, but it's
It's like the
similar. It's not the same triangle. It's not the same triangle. It's similar one. I'm gonna draw it here. This is the real R. This is the This is the shadow R, right? The same as here. So this is theta, and you can find, and this is 90 degrees. So you can find from this triangle. It's belongs to the previous subject, okay? You should cover that. You have it in the tutorial, fully explained, okay? Go back and see it, okay? Because I don't want to waste too
Why
much
did you
time.
put d phi?
Huh?
Why d phi?
It's because of the radian, because this is a small movement with the angle d phi, okay? So we found this one. It's r squared,
Toby has a question.
just in a second. Theta, d theta, d phi. Yes, what is the question?
Toby.
Okay, hi Toby. Toby asked us that the Jacobian of the spherical coordinate is not that horrible. Okay, so this is a matter of opinion, okay? So there's a way to do it with Jacobians, I agree, which apply to every system, but personally, I found it a little bit not that well understood by students. So I like to do it, you know, step by step by geometry and space. But definitely, your answer is better than mine. Okay, I couldn't put it better. Okay, so we have this dq. We know d. What is d? 2r sinus theta over 2. Yes? Don't forget that we have this integral. And we actually now have two integrals. The phi, the theta, as we expected. As we expected. Okay? So 0 till pi, which is theta, and 0 till 2 pi, which is phi. Around the world, around, right? 0 till 2 pi. Perfect. So there's nothing here in phi. So we actually have these 2 pi outside. And we start with this thing, which is k outside, r square outside, sigma 0. Nobody told me about it, but we are missing sigma 0. Sigma 0 outside. And we're actually missing all the sigma, right? We have also sinus theta, right? Wake up! Wake up! Okay? So we have this sinus theta, which is horrible. We have here sinus theta. And I'm about to faint out when I see this stuff. D theta, 0 till pi. Yes? And this one cancel with this one. Right? So this actually, this one actually died. So we can get rid of that. And, sorry, this one was squared. Right?
Yeah.
Oh my god, this is horrible. This is squared, this one actually contribute to us 2 over here, right? But it's killing this out squared. Right?
Yeah.
Because this one. So you need to solve that thing. Now you need to solve this integral. And it's not relevant to the class, okay? You can solve it. This one actually equal to, I honestly put it in a calculator. Just, the camera follow me? The camera follow me?
Sorry.
Camera follow me? I'm gonna walk slowly so you can test. Okay, good. So this integral actually equal to 8 over 3. And the question is done. Okay? No, you can.
Amazing.
But, this one also cancel out with this. You have only this. Okay?
Wait, how?
This.
It's theta over 2, right?
Yes, this one is, I'm missing 1 over 2. Theta over 2.
Theta over 2. This is.
Where is the theta? This
By
one.
the cosine. Yeah.
Cosine theta over 2. Okay, also.
No, here's a sine. That's the sine theta over 2.
Theta over 2, which is this term.
But it will just cancel once.
Right?
Yeah.
So, agreed, it's a really hard question, but not in the physics, in the math. So, I cannot help you with the homework, with the math. This is your own challenge, okay? So, this is
Even
the...
in Calc 2 we didn't have so
Huh?
much integral.
I agree, it's really
Physics 2
pain.
is just Calc 2.
It's a really...
Harder than Calc 2.
I think it's a really pain in the ass. I agree with you, the math here, I think it's redundant, but the concept were super crucial. You cannot be, I want you to be confident about the concept. The concept gonna be in the exam as well. Not the math, but the concept gonna be on the exam. Math, we save it to the homework. There's also important to, you know, to let you practice at these ideas, okay? Perfect.
Did you have another way of solving it without geometry or no?
What?
The question without geometry?
If you're gonna think about something, let me know. That's how I did it. It's the best way, best to my understanding.
Okay.
Okay? Cool guys?
Camera following you.
Camera following me, camera
It's following you.
I'm going back to this board and I'm gonna clean this one out, okay? So right now, we're gonna move to the next concept, which is Gauss's law. Okay? Who remember Gauss's... can you stop the video and we're gonna do a new one?